Welcome back, 8th grade. It is Thursday in your world, likely. Solving multiple step equations. So we're going to take what we did on Tuesday and on Monday and build on it from what we did on Wednesday, and we'll continue today. So, you know the inverse operations. If it's multiplication, we use division, and we figure out the answer is 34. If it's division, we use multiplication, and figure out the answer is 225. If it's subtraction, we use addition, and figure out the answer is 121. And if it's addition, we may need to use subtraction, and we get 97.5 equals 5. We've just run into a two-step problem. Now, hopefully you can see, if I simply do my division and do my division, I will come up with my answer that is 19.5. All right. This last one is a two-step problem. This is where we'll use PEMBA in reverse. You do subtraction and addition and get rid of those first. Then you're just left with a variable and a number on one side and numbers on the other side. We will be working through these. We'll need to see the work, and there will be a place to put your work in when you do the Google Forms. So learning to solve multi-step equations. To solve a multiple step equation, you may have to simplify the equation first by combining like terms. So first, combine all the like terms that we can, or by using the distributive property. Okay? So the easiest way is to jump into them, and seeing all this, I look and I go, we must first combine like terms. That is 11x. Then I see, I have another set of like terms. Positive 6, negative 2 gets a positive 4. First step, combine all like terms. Second step, try to get the variable by itself. Subtract 4, there's a 33. And 11x equals 33. And then the third and final step, I divide by 11, x then equals 3, and I have my solution. First, add like terms and get the new item where it's simplified. Then, start with addition and subtraction to try to get that variable by itself. Good, now variables by itself with a number, use division and multiplication, and we get to our answer. Let's watch what they do. Okay? They combine like terms. We did that in our first step. Then they get rid of that 4. So it's kind of a continuation of combining like terms, but it's across that equal sign, so we had to subtract and subtract. Okay? Then we're ready to use more inverse operations. Divide by 11, and we get x equals 3. We can check by putting it back in. X equals 3. So, when we put 3 back in where x is at, we get 24 plus the 6 plus 9 minus 2. That does equal 37, and it checks out good. Here, the distributive property we had. We need to do that very first. 4x. There's a subtraction sign, minus 24. Plus the 7, it's not inside the parentheses, so it just comes down, equals the 11. Then you're going to look for your like terms. There's only one x, but I can see I have a negative 24 and a positive 7. Negative 24 and positive 7 is a negative 17. So 4x minus 17 equals 11. Remember, think of that as negative, that is positive. We combine them together, we get our negative 17. Then, use our inverse operations. Add the 17. Add the 17. We get 28 over here. This leaves us with 4x all by its lonesome. Divide by 4. Divide by 4. And we'll see x equals 7. And when we plug 7 in here, we'll see that our answer is correct. All right. So, distributive property. Combine like terms. Then use inverse operations. And we're kind of going in reverse PEMBA when we use inverse operations. All right, so let's see. They distributed it. We then multiply. Now we're going to combine like terms. Then add 17, the inverse operation. Then we do another inverse operation, and x equals 7. We'll check it out by putting the 7 back in. Oh, whoops. We won't check it out. Here, we're going to combine like terms. There's no parentheses to get rid of. Positive 9, positive 4x. Positive 5, negative 2. So positive and a positive, so that's 13x. Positive and a negative. Oh, positive's bigger, so I'm going to have positive 3 as my answer. And that all equals 42. So we combine like terms. First step, I need to see the problem. I need to see the first step, second step, third step. That's what I'm looking for to make sure I can give you full credit. All right, we're going to subtract 3. Subtract 3 to our inverse operations. So we get 13x equals 39. Then we continue to do inverse operations. Divide by 13. Divide by 13. X equals 3. Remember, go back. Slow these down. Watch them. All right, let's watch what they did. All right. Say they combined like terms. Looked like ours. They did inverse operations. They did inverse operations again. X equals 3. Now they checked this one. We plug that 3 back in. All right. And it does add up and check out. See how they put the 3 in for the x's? If an equation contains fraction, it may be helpful to multiply both sides by the equation by the least common denominator of the fractions. This step results in an equation without fractions, which may be easier to solve. They're saying get rid of the fractions. I know y'all love fractions, but we might just get rid of them. So, 9, 2, and 3. Those are our small numbers here. We need to find the smallest number, the least common denominator that they all go into. I know they all will go into 18. So if I take and I distribute 18 to all these, and I distribute 18 to this one. So I've taken everything times 18. The thing that happens is we get rid of the fractions. So 18 times 7x over 9. Oh, yeah, that goes away, and this becomes a 2. 2 times 7, that's 14x. That turned into 14x. Now we've got to think of it again. We've got our 18 here. Now we're going to take it times this. That becomes 1, that becomes 9. 9 times x is, plus 9x. Notice I just bring the signs down. Let's think about it again. 18 over 1. I'm going to take it all the way over here. 9. Oh, that becomes 2. I'm reducing these. All right. So 2 times 17. That becomes 34. And it's a minus 34. Over here on this side, I can reduce. This becomes 6. 2 times 6 is 12. I'm rid of all of my fractions. If you need to, I have a lot of students that like to do it this way. Instead of writing out that distributive property, they do it this way. I'm taking 8 times 18 over 1, times 18 over 1, times 18 over 1. And then the distributing makes a lot more sense to them. 2 times 7, there's 14. 9 times x, there's 9x. 2 times 17, there's the 34. So you can, and a lot of students like to write that times 18 right in front of each problem. and that will work. Now, we look at like terms. Positive 14x, positive 9x, that's a 23x minus 34 equals 12. Now we're going to go to our good old inverse operations of plus the 34, plus the 34, and we get 46 equals 23x. Continue the inverse operations, 23 division by, sorry I said that weird. And that equals 2. We went through a lot of steps to figure out that was 2. We got rid of the denominator, so we had just whole numbers. Then we added like terms like we've done before. Then we did our inverse operations like we've done before. Only new thing was this. And I like saying, oh, what's the least common denominator? 18. So I take 18 times each of those. Give you a chance to look at that. And away we go. Okay. They're going to show that. 18 is the least common denominator. We're going to multiply both sides by that. They show it like this. I think it was a lot more helpful for the students in the past when you treated it like a fraction, so you could reduce before you multiply and write it in front of each and every one of them or by each and every one of them. It just made it simpler for students. Okay? So now they rewrite it and do that, so they've written an extra step. When they multiply those out, 14x plus 9x plus 34 or minus 34 equals 12. We distributed everything. Now we combine like terms. 23 minus 34 equals 12. We come back over here. There's the inverse operations. Add 34 to both sides. There's 23x equals 46. We do inverse operations again. X equals 2. All right, so we check that by putting that 2 back in. 14 over 9 plus 2 over 2 minus 17 over 9 equals 2/3. And when they do all their math, they've got to get common denominators, and it does come out to be 6/9 over 6/9. You don't have to go back and check them, but it is something you can do. This one, when they're all the same, that's beautiful, wonderful, awesome. Because then all you have to do, 4 over 1, 4 over 1, 4 times 4 over 1. Hey, those simplify. They're both 1s. So literally what it is the numerators without the denominators that are your answers, or that is your second step. So if they're all the same one, their least common denominator is that 4, and you know, oh, I can just get rid of those and we're good to go. But when they're not all the same one, it does change the problem more. Now we do our inverse operation step. Hopefully you're saying subtract 5, subtract 5. Negative 5, negative 1. Said those backwards. Negative 6. Divide by a 3. Divide by a 3. N equals negative 2. That we plug in there. We can get negative answers. This is the last year's class's hardest part. They did end up getting it, but it was hard for them. You guys are better with negatives, so hopefully it won't be hard. Let's see it and go ahead and see what they did. All right. All right, multiply both sides by 4. When they do that, they spread them out, use the distributive property, and they realize here's the problem we get. Now, we're going to use inverse operations, subtract that 5 from both sides. Then we use inverse operations, divide both sides by 3 to get that n all by itself. N equals negative 2. And solve. All right, we look at this one. What's the least common multiple? Hopefully the least common multiple for the bottom you see is 9. So if you take every problem times 9, you're going to get rid of all that. Now we're multiplying. Oh, so these simplify. That's 5x. That's a 1. That's a 3. 3 times x, 3x. Don't forget to bring that down. Bring that negative down or the subtraction down. That becomes 13. This one, That becomes 3. All right? First step, we got to add like terms. Positive 5, positive 3x. So that makes 8x minus the 13 equals 3. Please don't jump steps. I doubt you're ready for it yet. You might be. We do inverse operations. We do inverse operations. 8x equals 16. Divide by the 8. More inverse operation. Divide by the 8. X equals 2. All right? And we get our answer. So, got rid of the denominators. Added the like terms. Then did inverse operations, doing addition and subtraction, removing them first. Then inverse operations to get that variable all by itself by using division and or multiplication. And we get to our answer of x equals 2. All right. So they put theirs in. They do their multiplication, distribute it again. All right. They get 5x plus 3x minus 13 equals 3. Whew, same thing. They combined like terms. 8x minus 13 equals 3. From there, we use inverse operations. Add the 13 to both sides. Then more inverse operations. Divide by 8. X equals 2. All right. That is what we got. Here, we're going to check it. They decided to put the 2 in there. They do all the 2's and put them in there. Notice there were no x's by those, so they didn't have to do that. Get a common denominator. Oh, they do check out. Now they're going to ask us to write equations. These are the ones that are a little bit of a pain. Work together on them. Call me on them. It doesn't matter. On Monday, David rides his bike m miles. They tell you what the variable is going to be. M miles. M representing the miles we don't know. In 2 hours. On Tuesday, he rides 3 times as far in 5 hours. If his average speed for the 2 days is 12 miles per hour, how far did he ride on Monday? All right. So, on Monday, he rode m miles. We don't know how many in 2 hours. So many miles per hour. Per is another word for division. All right. Tuesday, he rides 3 times as far in 5 hours. So, 3 times m in 5 hours. Because 3 times as far. If his average speed for the day is 12 miles per hour, how far did he ride on Monday? So the average, 12 miles per hour. Round your answer to the nearest tenth of a mile. All right? So we've got some work to do. Let's make sure we set up the equation correctly. I'm thinking addition is going to go there. Hopefully you were too. But we're going to see what they come up with. David's average speed is his total distance for the 2 days divided by the total time. So, total distance, total time. So when they set up their equations, hey, m plus 3m, 2 plus 5, we did have it right, except I made them 2 separate fractions, and we have to look at doing the bottom and the top separately. I did make a mistake. And you could always put 12 over 1 to make it a fraction 2 to help you out. Okay? So when we combine the like terms then, get you 4m, that gets you 7. We want to try to get that m all by itself. So we multiply both sides by 7. If we do that, oh, that reduces. So we would get 4m equals 84. Okay? Then you see the division of dividing both sides by 4. M equals 21. He rode 21 miles in 2 hours on Monday. So, David rode 21 miles. All right. The other thing some of you may notice, if I take this by 7 over 4, we're left with just m. And this would be 7 over 4. 7 times 3 is your 21. So you can do it in one step, but that's just if you're real sure of it. Okay? On Saturday, Penelope rode her scooter M miles in 3 hours. M miles, and it was in 3 hours. On Sunday, she rides twice as far in 7 hours. 7 hours and twice as far. If her average speed for the days is 20 miles per hour, find this out. So, we want to combine our like terms, but let's make sure we wrote this out correctly. Miles on bottom, and on top, we're going to combine the bottom numbers and the top numbers, so it's not really a true fraction. All right? So total distance over total time, the average speed. All right? They're going to add like terms. M and 2m makes for 3m. 3 and 7 makes for 10. Wonderful. All right? They're going to multiply by 10 on both sides. They're doing inverse operations. Oh, that crosses out. Good deal. And that's going to make 3m equals 200. 3m divided by 3. 200 divided by 3. M is going to equal 66.67, or 66 2/3 of a mile. It's all about inverse operations. It's all about setting them up. And they will have problems just like that on there. Go back and look at these. All right. Got to send you out to tackle them. Thank you all very much.